So today we're going to take a look at math translations, and what we're going to do is we're just going to translate English sentences into mathematics. Now, we'll know we understand when we'll be able to translate descriptive math problems into these equations and then take those math problems and then solve for them. Good morning and welcome to Translating English into Algebra. Yes, but seriously, this is an important topic that a lot of you have had difficulty with in the past, and today we'll spend some time making sense of that. Okay? A lot of terms that we have studied in the past, well, have always just related to English. So now we're going to start making sure that we relate this to mathematics. And I know that some of you have done this type of work before, sometimes in grade 6, 7, or even 8. So for example, let's go over the English terms and then come up with an equivalent math term or operation. When we talk about something that is increased by something, we're actually talking about something growing in size. So when we grow something in math, like we grow a number, we usually say that we're going to actually increase it by literally just addition. Now, when we say that something is decreasing, we say that we're actually taking away from it. So we're actually minusing. Okay? So as you can see, really what's happening is here, when we talk about increasing, we're really just talking about an operation to grow something. Okay? Now we're talking about the binary operation of addition, and when we talk about decreasing, we're talking about the binary operation of subtraction. Okay? Now, when we say that something is a number, we're talking about a variable. Literally, anytime you hear something is talking about a number, we're talking about a variable. It could be x, it could be y, the second one could be y, so another one could be z. Now, when you hear the word a number, I want you to use x as your number. If you see that there is another number, I want you to call this y value another number. Okay? And then if there's a tertiary number, you do the same. Now remember, x, I want you to use as something that is a number. Now, when we say half of a number, we're literally thinking about either x divided by 2 or 1/2 of x, or if you wanted to, you could literally just write it as x over 2. Now, when we talk of the word of in mathematics, we're usually talking about the multiplication, okay, of two numbers. Please highlight that. Now, when we say the word is or are in an expression, we're actually referring to its equality. So something equals something else. And when we say the sum of, yes, we understand that means we're adding a whole bunch of different things. And when we talk about the value of, we're usually talking about the addition. For example, I could say the value of a number and another number is equal to 1. So your first number is x, your second number is y. The operation is x plus y equals whatever the final number was. Now just take a moment and make sure you take all that down. And please make sure you enter today's date at the top of your sheet. Now, when we're translating English into mathematics, a lot of the times you guys don't tend to let me know what each variable is, right? So that's why I say here that you need to identify the equation, the variable. I need to know what each of the variables are in my equation or series of equations that we're using. Now, when we do so, we're going to use a let statement. A let statement is essentially like setting up a program or setting up all the settings in your games, like making sure that you've got anti-aliasing on your Call of Duty game before you start. It's almost like saying, okay, this is what all of these things are going to do, and we're going to use these things to solve a problem. Now, if we were using COD, it would be say, okay, I got to go and set up all my anti-aliasing. I have to set up all my ray tracing. I have to make sure that my latency is low. So I'm going to go and set all these different variables. And those variables that I set up in my setup for my game allows me to go and play my game better. It's the same thing. If I let the reader know what each of the variables are, life is good. So, and then we write our equation. Now, for this next problem, it says, we've got some key words here. It says half of a value. The next thing it says is it's decreased by 7. And then finally it says is 1. Okay, so it says half of a value is decreased by 1. The first thing that you need to do is you need to tell me what value is. So we're going to say let the letter x be the unknown value. Now when you're writing these solutions for me, you don't necessarily have to go and write in quotations x be the unknown value. So the thing that we're looking for. So remember, x is the unknown value. All right, so now, once we've established what we're looking for, we have to decide how we're going to write this equation. So, this says half of a value decreased by 7 is 1. So, I'm going to write this in the colors that we have for each. So it says half of a value. We've just said that x is our value. So x, and then it says half of that value. So what we're going to do is we're going to divide it by 2. And then it says that this thing is decreased by the number 7. So we're going to subtract 7. Now, since we're subtracting 7, and then our final statement of our final clause is 1. So I'm going to write that in green. Equals 1. So our green matches with this. Our red section matches with the -7. And our yellow matches with our half value. So now I'm just going to rewrite this in just regular colors. And then we're going to do our problem. So first of all, we need to get rid of the 2 on the bottom here. So we're going to multiply by the LCM of 2. The LCM is 2 in this case. And we just multiply each numerator by 2. So we end up with 2. X over 2 times 2 is just x minus 14. And then moving the 14 over to the other side gives us x equals 2 plus 14, which is x is 16. And you know how I always love the fact that you're going to go and state what your variables are and find your final answers. Now, since this was a written solution, I want you to say your final statement. You would say, in math, therefore, the value is 16. Done. If you think about it, you're going to get a mark just for the equation. You're going to get a mark for identifying the fact that you're using the LCM to simplify. Possibly a mark for this part here, and a mark for this, and a mark for this. These are where you could possibly get marks. As you become more sophisticated with the work that you do, I will reduce the number of marks, the significance of something like this. Alright, now, the only reason I would do that is because something like this becomes trivial with how you do this over and over again. Now, this next problem says, each day Joe earns $50 plus an 8% commission on sales. These introductory statements, these let statements, give us an idea of what we're looking for. So let's let X be the daily sales. Some of you might use the letter S. I would warn you against the letter S because a lot of times when you're writing long tests over a long duration, you guys tend to mess up the letter S or mix it up with the number 5. And then your numbers end up being about 5 times larger than you normally expect. So I tend to use the letter X as much as possible, and then use any other letters like the letter P for pay. So let P be what Joe earns in a day, because that's what we care about, his pay, right? So now, in order to give an equation that describes Joe's pay, we could say Joe's pay equals, well, it says, if you think about it, it says the $50 plus his commission. Now, you know that commission, based on either your business class or the math that you studied before, is equal to the number of sales, and then we're going to times it by the percentage. And remember, the percentage is as a decimal. Now, you could either write it as a decimal or a fraction. It's up to you. So, here we go. So that means P is equal to 50 plus, well, X is his daily sales, so it's going to be 8% is 0.08 X. Or you could write it as P is equal to 50 plus 8 over 100 X, which turns into this simplified form. P is equal to 50 plus 2 over 25x. And then you would use something like this to do some form of optimization or maximization of profit, depending on the rest of the problem that was described. So your seat work for today is you're going to basically read examples 1 on page 9 of the text and get examples of your word math. The other thing I want you to do is I want you to pick up a textbook from me. And what I'll be doing is I'll be storing electronically what textbook you have, and then once everybody has a textbook, I'm going to make sure that everyone signs off for that textbook so that at the end of the year we can ensure that everybody has returned all their textbooks. So for your seat work, just read example 1 on page 9, then I want you to try page 17, 1 to 3, and check your work using the answers in the back of the textbook. Now, after completing the Translating English to Algebra handout, I want you to compare the answers that you got with a peer. And please note that I'm also going to take a snapshot of page 17, number 1 to 3, so that you can actively do the work at home in case you leave your textbook at school. Okay? And then I want you to do the practice sheet that I've handed out to you. And there's an extra challenge that I want you to take a look at on page 18, number 18A. Have a good day, guys.